and this facility is being utilized by research scholars, the master students in University of Rajasthan. And this presentation was held on the very first day when this program Vigyan Utsav was started. So the point is that the R&D infrastructure that has been created in Rajasthan, either by central government organizations or even by state government organization at universities or even at colleges also. So the point is that such kind of R&D infrastructure need to be available.
Students can be benefited by utilizing these facilities. Let me share my presentation. Uh, so are my slides are in full screen mode?
Yes, sir.
Yeah. So we are CSIR Siri Pilani, which was established in 1953 by Pandit, then first Prime Minister Pandit Jawaharlal Nehru. So our mission is mission and vision are to become. Our vision is to become a globally renowned destination for scientific knowledge, research excellence, and innovative technology in electronics, as well as sciences and engineering, with high social and strategic impact. existence of this center came up from funding from CSR CD, DSR, and state DST Rajasthan. They provided various funding support and various schemes. From DSR, we got Common Research Technology Development Hub, primarily in the field of renewable energy and electronics. From state state DST Rajasthan, we got the support, financial support for the under rural technology business incubation. Not only providing funding, these organizations are time to time giving the motivation and guidance to steer our facility creation and the facility creation, as well as guidance to enhance our test facility and other aspects. So today, primarily concentrating on the Jaipur Center facilities that are available. Am I audible? Is there any?
Yes, sir, you are audible.
Okay. So today I am primarily concentrating what are the facilities that as a center we are having. I will be covering what are the electrical facilities. Under the electric facilities, I will be covering the solar grid-tied inverter test facility and basic electrical parameter test facility. Then we have sample characterization test facility. What are the various things that we are having? That is spectroscopic based and NMR based characterization test facility. The other thing will be the electronic fabrication testing facility. What is the fabrication capabilities that we can provide to the customers or the scientists or the academicians, so that they can take up any design and do a small scale or pilot scale of 1,000 or 10,000 pieces without much human resource incorporation at their end. Also, we are having the workshop facility that I will be covering. The last one is what are the primary R&D activities that we are carrying at the center, so that any member who are interested in the R&D activities that we are carrying out, or who wants to utilize our R&D capabilities, they can also look into it. So first one, I am covering with the solar grid-tied inverter facility. We are an NABL accredited grid-tied inverter facility setup that we are having. Question is, all solar products needs to be complied by the standards of MNRE. As we can see, we are moving from a carbon release to a zero carbon setup as a country. So that in that case, we will be incorporating more and more renewable energy based products, primarily in the field of solar, subsequently for the wind and other things. So here we created a solar grid-tied inverter facilities, and we got enabled accreditation for this test facility, and our accreditation is valid from October 21 to October 2023. So the specs will be, we are having a 10,000 watt 15 ampere, that is 10 kilowatt solar array simulator, which will generate the solar characteristics of the power that are required to test an inverter. Also, we are having a regenerative grid simulator of 30 kilowatt capacity. Then we are having an anti-islanding test setup, which will providing a load of 30 kilowatt. So the various loads can be tested across using this load. So the various systems like inverter, UPS can be tested against this significant load, because primarily when we want to have a load of this capacity, it is both cost incentive as well as the technical incentive. So anybody cannot afford. So what are the standards that we comply using this test facility, primarily in the terms of NABL or BIS? We can calculate the MPPT, maximum power transfer efficiency MPPT, as per EN 50530. Then we are having we are complying with IS 61683 1919 for calculating the inverter efficiency under various test conditions or various loading condition. What will be the efficiency of the inverter? How it is behaving if my load is varying at the outlet. Then we are having a IEC 61727 photovoltaic systems characteristics of utility interface. Whenever we connect a inverter to the grid, how the inverter is behaving, whether it is fulfilling the characteristics of the utility interface or not. Then we are having IEC 62116, which is testing of island prevention mechanism. What happens when the load is behaving, when we are having throughput higher, or when the grid is behaving improperly? What is the action of the inverter? It should comply against these standards. Who will be the beneficiaries? Inverter manufacturers, UPS manufacturers are primarily beneficiaries. Also, any startup who wants to develop their products they can use this test facility to test their designs, uh, against the national standards. What are the key aspects? We created this facility and we validated this setup against the other test laboratories, national level test laboratories. What happens is, in most of the organizations, we are also having certain test facilities. We create this facility as per our understanding, but we need to validate these test facilities against the compliance of the other reputed national laboratories. Then only we can give the accurate test results to the end users. Otherwise, there will be a little bit of ambiguity whether our test setup is working fine or not. So we carried out the interlab comparison against the national reputed laboratories like CPRI Bangalore, NIC Gurgaon, etc. Not only the publicly funded organizations, we carried out the interlab comparison with the globally renowned laboratories like TU Hand. So there also our results are in compliance with the national standards. So this is our scope of accreditation, the certification of accreditation that we got. So this is the scope, that these are the parameters that we can test, like what is the energy efficiency, what is the static conversion efficiency, all those things. Not only we test the, we provide solution for the testing, we can give the inputs. If suppose if any user wants to improve his capabilities or improve his design modification, we will also provide the technical support also in that aspect. This is our total test setup. There we are having a solar array simulator that is of 10 kilowatt 10 kilowatt capacity. We are subsequently increasing to 30 kilowatt by this end. Then it will be connected to a inverter under test, and this inverter under test will be connected to the grid simulator, because we cannot directly control the grid. So we are having a grid simulator of 30 kilowatt capacity, and also the RLC load, which is of 30 kilowatt. These two parameters we will control: what is the behavior of the grid and what is the behavior of the RLC load. When we are testing this inverter under test, we'll simultaneously measuring what is the efficiency in terms of power, voltage, current, timing, etc., both with the power analyzer and the digital DSO, digital storage oscilloscope. And these systems are controlled with a PC. These are controlled through a data acquisition system. This is our primary test setup. As I mentioned earlier, we carried out this our test setup validation with the other test laboratories that are present in the national level. So the labs that we took care is the 5 labs that we done this interlab comparison. That is CSR Series Jaipur, NIC Gurgaon, National Institute of Solar Energy, CPRI Bangalore, United Laboratories Bangalore, and TU Raihan Bangalore. So when we test this test laboratory, it should have a certain Z score. Z score is meant by 0 score. Our results are, when we compare these results, it should be nearer to 0, and it should be, and it is limited as +-2. Our results are almost in the band of +-1 only at this moment of time. We will keep on increasing, even though there is no need of keep on increasing the efficiency of this one, but we will try to achieve the Z score to nearest possible level that can be achieved. The other test facilities that we are having is, we can measure all AC related, electrical related parameters, that is AC current, DC current, AC power, inductance, capacitance, and AC power. And we are having wide range of measurement, that is, we can measure AC current from 10 milliampere hour to 65 amperes. And also that is up to 50 Hz. Beyond 50 Hz, we are having capability of 10 milliamperes to 10 amperes. So these are the various ranges that we can cover. So presently, we are having the testing accreditation for only the grid-tied inverters, but we are planning for having the calibration testing facility for all the electrical parameters. So that whatever the authentication that is required once we created a test lab will be fullified, so that we can give the 100% accurate results to the end user. There will be no ambiguity in the measurements that he is taking, and the test procedures are up to the national or international standards. It's not like that we measured as per our convenience. No, all the test parameters, all the test cases will be against a standard which is evolved over a period of time. So these things, this is the basic advantage of having a going for accreditation or a accreditation body. Now I am covering the sample characterization. So we are having a, just a second, sample characterization. So we are having a sample characterization capability to test samples of various categories for liquids, semi-fluids, and milk powder or powder format. Presently, we are having UAVs to FIR capability test capabilities. In this case, we are having both tabletop systems as well as the portable systems. Presently, what happens is whenever we do a testing, the sample needs to be brought to the lab, do the analysis or testing, and generate the data. We are having a UV visible spectrometer up to NIR, then we are having NIR to MIR, both in various categories, both a portable level as well as the field deployable level. So that this, in some cases, it happens like that we cannot bring the sample to the lab, we need to do the on-site analysis. If you see any portable device, this is a typical UV visible spectrophotometer in a benchtop scale. That is, it is having a 3 feet by 2 feet or 2.5 feet by 2 feet. It is a basic benchtop model. And also we are having a portable scheme where we having a light source, NIR light source or UV's NIR light source. And we can measure the sample, and then we will be having a USB connected portable spectrophotometer which can be connected to a PC or a laptop or any portable device. So in the traditional benchtop model, we are having UV visible spectrophotometer for a wavelength range of 165 nanometers to 1110 nanometers. In this case, we are having a detectors of PMT and InGas 1. The light sources are Xenon arc lamp based light sources. What are the various modes that we can test using this scheme is we can measure the reflective modes and absorption modes, and also multiple scanning modes with a various angle, with a various excitation angles. The typical resolution of the system is less than 1 nanometer. What we can test is we can test water, liquids, honey, milk powder, etc. Presently, we are testing extensively for honey, milk, and edible oils. The other thing which we are having a portable test setup, which is for a wavelength range of 190 nanometers to 900 nanometers. Here the detector is linear silicon based CCD array. Since it is a portable one, it is almost the size of a credit card, with a credit card size of in the length and width, with a height of around 15 mm height. So this can be easily portable. And also the light source is also again portable light source. It is a combination of deuterium and tungsten. This tungsten and deuterium is excited based upon the requirement. Suppose if you want to go for the more useful UV, then we will be using deuterium based. Otherwise, if we want NIR, then we will have tungsten. Here we are having a light source from 190 nanometers to 2500 nanometers. Here we can do multiple range of testing at the field level, that is reflective, absorption, Raman, other test cases that we can test using this model. Also, we are having a multiple different types of probes that are using. We are having a direct fiber probes, which is having a single fiber. We are having a multiple fiber cores where there is a dedicated transmission as well as the absorption layer fibers. But here the resolution is little bit less, but it will be very much useful for the field deployable applications. Or when we are having a unknown samples which we don't have, the samples cannot be integrated into a dedicated benchtop model. Those samples we can be integrated or testing using these schemes, portable schemes. Similarly, in the NIR range, we are having two spectrophotometers, NIR spectrophotometers. One is NIR spectrophotometer for the wavelength range of 680 to 2600 nanometers. Here the detector is InGas arsenic uncooled version, not uncooled, ultra cooled version. The light source is tungsten halogen lamp based. Here we can test only the reflective and the transreflective mechanism. Here we cannot do the absorption or other schemes that we mostly do with a traditional benchtop models. Here the bandwidth is 10 nanometers, but here the wavelength range is quite long. So here the bandwidth is 10 nanometers with a resolution of 0.3 nanometers. Primarily, we are using this for the grains, liquids, honey, milk powder, etc. Also, these equipments can be used for the pharmaceuticals also. The other NIR equipment that we are having is FTIR. Here the wavelength range is 4500 centimeter inverse to the 650 centimeter inverse. It is a beam splitter based configuration, and it is a microsync interferometer based configuration. Here the resolution of the wavelength is in the order of 4 centimeters inverse. So primarily these two samples we will be using for various honey related applications. So using these equipments, what we are doing means we have to categorize. We developed our own R&D system, R&D projects where we develop various products for oil characterization or adulteration detection in edible oils. So one such case study I am sharing with you. First one is the edible oil blending combination that we detecting. We are having primarily 9 different segments of oils that we directly bought from the market as well as the oil industry. The oils are categorized as mustard oil, olive oil, soybean oil, rice bran, olive oil mixed with the rice bran, groundnut, canola, sesame oil. So these different categorized oils that we tested using this UV visible spectrophotometer, NIR spectrophotometer, as well as FTIR. This is an experimental results of a typical NIR spectrum. So if you see on the x-axis, it is wavelength. Since this is a software that is controlled by the instrument, so we are unable to enlarge the wavelength on the x. But typically the wavelength range is 900 nanometers to 1680 nanometers, where the literature is available. This is the particular bands that we can differentiate between various edible oils. On the y-axis is the intensity of the detector. Typically seeing a spectrum, it will not yield any results. But what we are having at the center is, we get a spectrum, we can we can uh, we can characterize this, what is exactly the spectrum that is information that it is sharing using. We are having a PC based software that is software that are available for the soft computing techniques. So we will evaluate using the data that is generated by any spectrum, whether it is UV visible or FTNIR, using these softwares. But the method creation and the method validation and everything will be done by us only. The software will only provide the statistical methods or the tools that it will create. So using one such statistical technique, that is principal component analysis, we are able to differentiate various, or we can group various different types of edible oils. That is from canola, groundnut, mustard, olive. Here we can see all can be easily categorized with a principal component analysis of principal components 1 and 2. Similarly, we done the same thing with the UV visible spectrophotometer. Here our main focus is on the adulteration and the blending. So here we use a pure mustard and pure sunflower oil. If we see the case of a mustard oil is having a much more economical value when compared with the sunflower oil. So people generally mix the mustard oil with the sunflower oil. Up to 20% is allowed by the FSSI, but beyond that it is not permissible blending. But people, out of their interest in the out of their finance or to make more financial gains, they generally mix these samples. Here also we can see where the where we can where we generated the data, and this is the typical region of interest from a 300 nanometers to 550, where we can segregate various oils. And we also did the soft computing techniques applied on this spectrum, generated spectrum, and here we can differentiate various blended oil. The pure mustard oil is at this level, and the pure sunflower oil is at this other end of the spectrum. Basing rest of the combinations are lying in between these regions. So using these schemes, we can differentiate between various blending mechanisms. So we are having the test facility not only the generating the spectrum of the oils or the samples that we are using, we can also characterize using the soft computing techniques. The other sample characterization facility that we are having is the fluorescent and absorption spectrophotometer. So here we are having a dedicated dedicated light source, both to test the absorption as well as the fluorescent scheme. The fluorescence ranges from 250 nanometers to 1150 nanometers. In the case of fluorescence, the detector is a CCD based detector. In the case of excitation, it is a linear CCS array, linear silicon photodiode array. Here also we can test various liquid, powder, fluid samples. These are the test results of we bought it from Horiba, and these are the test results of a protein quantification in a serum from an excitation wavelength of 250 nanometers and the fluorescence emission detection from 265 to 500 nanometers. So this is the typical range. Here we can see when we see the graph, it is all graphs are lying on one top of each other at the bottom level. If we zoom in a little bit further, here the system can be easily quantified micro level of quantification in the range of milliliters of sample. The next one is the macro Raman. It is called as macro Ram from the Horiba. Here also we are having a dedicated laser-based 785 nanometers laser-based macro Raman system, and it is complying with the class 1 safety level. And the laser power categorizes 7 milliwatt to 450 milliwatt. Here also we can test various schemes of Raman spectroscopy for primarily for liquids and milk powder samples. Presently we are utilizing this one. This is one such example that is shared by for the Raman by Horiba itself. It is a rapid polymer identification for excitation wavelength of 785 nanometers of various nylon categorization. The next one is we are having a dedicated sample characterization for the milk. One is the primarily we are using for the milk. It can be categorized for other samples. In the milk, it is used to determine the moisture and the solid analyzers. This is the test setup or facility that we are having. Here we can measure the moisture from 0.01 to 99.99% of moisture can be measured with a typical resolution of 0.01% of resolution. The energy source is it's a quartz halogen infrared plus microwave. So these systems are again validated against the international standards. Presently, we don't have exactly microwave or infrared standards that are at the national level that are available. So these systems are complied with the international standards that AOAC 985.14 subsequently. Also, we are having a rapid NMR based fat analyzer where we can measure the fat of various milk and milk powder samples. Typical range is 0.05 to 100% of fat content. It is a direct method, direct isolation measurement of hydrogen, protons, and fat molecules. It is an NMR based solution. So it is a very rapid and instantaneous measurement when compared with a typical fat measurement in any traditional Gruber method or ZLAL method. It is a quite tedious or lengthy process. These measurements are NIR based, and these techniques are proved at the global level. Maybe subsequently these methods will also be accepted at the national level. So these are instantaneous or direct measurement, and we can get the results instantaneously. Primarily, we are using this facility for the milk fat measurement or milk moisture measurement in milk samples and milk powder samples, which is our core R&D area at the center. Also, we are having NMR, traditional NMR of 60 megahertz of 1.4 Tesla magnet based one. This is a no cryogen based magnet, so it is not harmful. It can be used at the lab level. Here we can measure dual tuned nuclei can be measured 1H or 13C or 1H or 31P can be measured at the same instant. Any two combinations can be selected when measuring the samples. Here we are having a locking scheme of deuterium with non-deuterium options. Presently, if we see the honey adulteration, most of these new methods are coming use the NMR based only. So people are developing their own library to identify the honey adulteration, which has become very prominent in the last 6 to 8 months. So we are also creating our own method for identifying the adulteration of the honey samples. And also we are having a traditional AAS, which is a benchtop model. It is a 8 lamp based configuration. It is having a normal typical atomic option spectroscopy techniques. Presently we are having 16 lamp turret, and we will be incorporating more and more once we have found the need and necessity to increase the capabilities. To sum up, here we are having the total spectral sensing from the UV visible range. We are having a initial level of spectroscopy, sample characterization at the lab level. We can do the scanning. We send the data to the chemometrics lab where they will analyze the data and categorize the data based upon the chemometric technique. So we are having the capability not only test, we taking a decision on what type of sample and what it can be characterized. Primarily, we are using for the soil health, dairy analysis, smart farming, and food scanner applications only, based upon our R&D capabilities. As I mentioned earlier, we are also having a product design and fabrication. What happens is whenever a startup thinks they are having a small prototype which they can fulfill 5 to 10 samples. If they want to test these samples for making 100 or 1,000 such products at their end, in general, what happens is they have to invest in the manpower for the production of 1,000 pieces or 100 pieces at their level. So what we are having here is a high-speed electronic pick and place facility where we can fabricate multiple electronic boards with very minimal human efforts. So we are having those capabilities. It is a both optical and the vision-based system optical vision and laser based system. So the systems can be placed on any PCB with a resolution of 3 micrometer resolution, and also it can pick a component of size 0402, that is roughly 0.5 mm to 0.2 mm size, and up to a large size of 120 mm by 90 mm component can be automatically picked using a robot, and it is placed on any PCB. So the end user can concentrate on the newer designs and the marketing techniques. You don't need to focus on the production capabilities. Those system facilities are available at the production, design and fabrication level at our center. And also we're having state-of-the-art CAD tools at this facility. Also we're having workshop and 3D printing and prototyping facilities. In the terms of the data analysis, we are having Unscrambler is a 64-bit version where we can test with the various techniques of new soft computing tools or data analysis tools that can be tested using both the Unscrambler and MATLAB. This is our manufacturing capabilities. Here we are having the spectroscopic techniques or test facility having up to MAR range. What happens is any new sample comes, we need to modify the sample holders, or we have to develop our own sample holding mechanism. So for that purpose, we have our own dedicated workshop. So minor modification, the sample holder mechanisms or product prototyping can be done at our end only. So the user need not to go outside the lab or the center. And the last, so these are the 4 different projects that are presently running at our center. We are having a DST funded soil monitoring system, on-site spectroscopic soil health analyzer using chemometric analysis and cloud services, which is funded from DST Central DST. Then we are having various CSR missions, that is Atlas mission and Ideal mission, where we are developing, for Atlas mission, we are developing adulteration and blending of edible oils using an air spectral sensing system. And in the indigenous mission, we are developing our own spectroscopic system, single beam UV visible spectrophotometer. Presently, 85% of the spectrophotometers that are available in India are the imported, whether it is from Ocean Optics, Hamamatsu, or Thor Labs, etc. They are all imported. Very few Indian companies are there where there are dedicated optical bench or optical lab to develop the new spectroscopic platforms. So we are developing our own indigenous spectrophotometer using optical components and the detectors at the indigenous level, so that the dependency on the external foreign exchange will be limited. Also, we are having the industrial sponsored activities from various MSMEs and the line ministry. So thank you. Any questions or any queries, I am happy to answer.
Thank you, Sai Krishnaji, for the presentation and sharing about the R&D infrastructure available at either at Siri Center or, and of course, the main focus at Common Research Technology Development Hub at Jaipur Center itself.
Yeah.
So
which you are one of the which you are one of our mentor. Starting
not mentor, so we are basically a collaborator, and it's our collective job to serve for the society. And of course, the R&D infrastructure that at Jaipur Center CSIR Siri Plani has created is really state of the art. And I request all our colleagues at State Assembly Council, and apart from State Assembly Council, of course, from the academia and SMEs, they should take the benefit of the R&D infrastructure available at Jaipur Center at Common Research Technology Development Hub. Of course, this CRTDH hub at some startups were also housed. So it's a means good facility, and since your mandate is also to work under this in this direction in electronics and semiconductor sensors, so there are many things that one can explore. So nice of you, Sai Krishnaji, for sparing time and sharing the things.
Our pleasure, sir.
Jointly organized by the Department of Science and Technology, Government of India, and Department of Science and Technology, Government of Rajasthan. So thank you.
Thank you, sir. Thank you.
So for next presentation, I will request Sri Bhuvnesh Mathurji from Rajasthan Pollution Control Board. And Rajasthan Pollution Control Board is the regulatory agency basically in the state of Rajasthan, and monitoring all sort of pollution related parameters across the Rajasthan state, either at industries or means in public domain also. Dr. Shri Bhuvnesh Mathur is Senior Environmental Engineer and in charge Textile and in charge Project Training and IEC activities. So I request Shri Bhuvnesh Mathur ji for the presentation.
Thank you, sir. I hope I am audible.
Yes, you are audible, Mathur ji.
The State Pollution Control Board mandate is slightly different from, I believe, all the other people who are there to present. I would just like to briefly introduce about the activities of the board and how our activities are in sync with the activities taken by Department of Science and Technology and other research agencies. We are not actually much into research directly, but we are taking support of a lot of agencies, including CSIR, including IITs, MNITs, and other agencies which are having certain expertise in certain field to get research work done on our behalf, study projects as well as new product developments. So that is the area where we can think of collaborating with the other agencies which have direct expertise in the research and development or carrying out various study activities. So the State Pollution Control Board was constituted under Water Prevention and Control of Pollution Act 1974 and then given mandate of Air Pollution Control Act and Environment Protection Act, and then host of notifications issued under Environment Protection Act like plastic waste management, municipal solid waste management, biomedical waste management, construction and demolish waste management, and things like that. So our generic mandate in the Pollution Control Board is a lot of people think it is only limited to control of pollution in the industries, but we are being mandated into control of pollution, maybe from the wastewater generated from industries, domestic wastewater from municipalities, or municipal solid waste, which also include plastic waste and demolition waste, to biomedical waste. So air pollution become our domain, water pollution become our domain, noise pollution control become our domain, and solid waste management, including hazardous waste management, becomes our domain. So that is the area where we are working. We are presently having, in addition to the head office at Jaipur, along with the central laboratory at Jaipur, the 25 regional offices at different districts and 12 regional laboratories at various locations in the state. These laboratories are very well equipped
Sorry.
to. Sir.
Mr. Mathur, sorry to just disturb you. So, whether you will be making any kind of presentation or means?
I think I have a presentation, but I think it will be more better if I just directly communicate and explain the various aspects. So I don't really want to otherwise reading will I have quite a dry presentation if I get into it. So I would just like to discuss.
Okay.
So we have 12 laboratories which are competent to carry out analysis of air parameters, water analysis, wastewater analysis, soil, sludges, and of course monitoring of noise level. So our laboratories are also very competent, but we are not directly getting into research work. We are into monitoring work. We have also got continuous air quality monitoring stations presently at, I think, 10 places, and planning to extend it to 25 other locations also, so that we can get a total mapping of the state air quality. So AQI we are on a daily basis reading about, especially Delhi and NCR, but we intend to get the air quality mapping done on a regular basis for the whole of the state. So that way we will be having about 35 continuous air quality stations in the state.
Every district headquarters.
At every district headquarters. So along with that, I just give you briefly about how we are monitoring the whole state. So along with the carrying out sampling and analysis on the case-to-case basis from the industries or any point from where we get information about some pollutant being discharged, whether it can be air, water, or wastewater, noise, or any other activity, we do continuously common effluent we have been doing continuously monitoring at various locations of National Ambient Air under National Ambient Air Quality Monitoring Program, having total 39 stations spread in Jaipur, Jodhpur, Kota, Udaipur, Alwar, Bhiwadi, Bharatpur, Chittorgarh. Here we on the on the basis of gravimetric and absorption method are carrying out air quality monitorings. Similarly, we have got 10 continuous air quality. In addition to these 39, we have got 10 continuous air quality monitoring stations located at Jaipur, Jodhpur, Kota, Udaipur, Alwar, Bhiwadi, Pali, and Ajmer. And as I told you, we are planning to install 25 more stations which are under pipeline. We will be having at least one station in every district of the state. Other than that, we are also doing continuous emission effluent monitoring from the industries. We have got installed continuous air quality monitoring stations for water as well as air into industries which we consider as 17 category industry or grossly polluting industry. We have identified such industries as 454 number, and out of those, out of them, 327 units are continuously being sending us a report through online reports, which we are continuously monitoring at the data center developed by the state at its head office in Jalan Institutional Area, Jaipur. Now, coming down, this is what the board and board with its limited infrastructure, having a technical and scientific wing with total strength of, I think, about 400 total strength of technical and scientific wing. We are can do a general monitoring of the industries and some continuous monitoring, as I explained earlier. But in addition to that, for research work, we have this year only we have issued guidelines for submission of research and development project for financial support. This guidelines was developed keeping in mind the guidelines issued by the Department of Science and Technology, Rajasthan. We have taken most of inputs from the Department of Science and Technology guidelines here. But our focus is on the projects which are for the upgradation of environment and the projects which can lead to recycling and reuse of the waste material. That is our major focus area. We have classified the projects under two categories. One is major projects, which is having financial sanction of more than 15 lakh rupees, and a minor research project which has a sanction of less than 15 lakh rupees. So any agency, good research institute and academic institute can get into collaboration with us. And obviously, DST has a main mandate to support that. But in addition to that, if there are certain projects which are related to conservation or upgradation or restoration of environment, the state board will be willing to come forward and support such study and research projects. Especially, we are looking forward towards academic institutes which can be both way supportive. At one end, the students can be benefited by the study projects and have a greater perspective of environment, and in long run can be very supportive in our cause. On the other hand, such development will assist State Pollution Control Board into getting solutions. Though we are in statutory bodies, but for last few years, we have trying to handheld the organization into environmental solutions so that the state as well as the overall cause of environment can be supported. We have in mind two projects right now, which if anybody come forward, we can always collaborate, and which we may be going to be floating that project also, or if somebody comes so more to do that. One is related to the area Sambar, where after purification and of that, they take sodium chloride out, but potassium chloride. Then another residue is sodium sulfate. That is having a problem of being getting disposed, and it is stacked around the lake, and then in rainy season it may find its way back to the river, and then the concentration of sodium sulfate increases, and the harmful effect of it is evident. So, and this sodium sulfate, after certain purification and some modification, seems to be very useful in some industrial activities. We have been told by Salt Commission that in some areas that is still being used. So we are very interested to give some study project to any research agency which is interested in to find a solution and to convert this waste sodium sulfate into some useful product. Similarly, from textile sector, we are having a lot of sludge generated, especially in Balotra. When other area, it is being in a waste sludge generated from Balotra, Pali and Jodhpur is utilized by the cement industry in burning. But Balotra has a specific case where the sludge is having very high chloride. So, cement industry is not willing to take it. So we are also looking forward if somebody can come forward, maybe convert it into some building material, road filling, or some change in chemical or precipitation of separation out of chloride, and making it useful for reutilization purpose. So these are the two projects which are on hand available with the pollution control board, where we want a collaboration with some good agency, academic agency, or a CSI agency, or any other research agency which might be interested into taking this as a project. We will be willing to support financially and also give all inputs for these projects. Now coming back to the what we have done in the past, we have already done few projects in last few years. To highlight one we have done with CSIR Roorkee, that was related to utilization of quota stone slurry. So with the help of a CSIR and CBRI Roorkee, we were able to get the products which were outdoor paver blocks, outdoor tiles, and some lightweight partition walls. And that was quite a successful project. We are able to get one project commissioned in Kota, which is successfully running and producing building material out of this waste material. We are also having two projects under pipeline where we may be able to sanction it and probably in this month only, where we can give the project for implementation. So similarly, we want to develop in other areas also where these can be usefully done. Recently, we have done a project with MNIT, where two projects with MNIT. One is where utilization of marble slurry powder for production of HAP. This was done by chemical engineering department, where they have used the properties of calcium in the waste material and used by it they have able to synthesize the HAP. HAP is used mainly for defluoridation of drinking water. Now we are that has been established at the laboratory scale, and now we are looking for channel partners in industry who can come forward and put up a pilot plant to manufacture it and then upgrade it to a full-fledged plant. This is one project. We also do similarly when such project is the first one who is going to come forward to do it. We may also support it by the grant in aid of up to rupees 25 lakhs. We have done similarly in Kota also, in Kota Stone Slurry case also. We have given fund of about 18 lakhs to Passion Welfare Society to set up the project. That was apart the cost we bond and shared it with CBRI Roorkee for development of the project. So we are looking forward to some agencies who can upgrade this HAP into marble powder into HAP through pilot plant level. We have also done a project through civil engineering department where sand is modified for the purpose of replacing, having some better properties and having some change as compared to activated charcoal. So in the textile waste, when there is a color and color removal is very important. So we have got it into this. They have modified soil, activated it so as to give it properties where it can be utilized for filtration, where the color removal can be achieved. So this we have also put up a pilot plant, and but I think it needs further upgradation into it. Similarly, we have also supported Wildlife Board into its endeavor toward conservation of Great Indian Bustard. So the project was taken by Wildlife Board, and I am very sure most of you must have read it that the Forest Department, by the support, has been able to breed the Indian great bustard, which is almost on the verge of extinction, and submit lot of recommendations, and especially in the light of solar electricity and wind energies, which and the transmission lines, which are becoming cause of deaths of lot of these birds. So revival of this Indian great bustard has been taken by Wildlife Board, though they have got fund from CSIR and other agencies also, but we were also able to give some contribution into it. Then presently looking at the water scarcity in the state and looking to how siting of industry should be done, that major water intensive unit do not come into the areas which is sensitive to the water availability. We have done a project on benchmarking the water resources and developing siting criteria for establishment of industrial area. We were able to give some policy guidelines to the government based on this. Then we have also supported Forest Department in a lot of its project, like restoration of this Nala into passing through Malviya industrial area, and some forest developments and all this. Recently, the intervention of board was toward the air quality. So, as it is quite common reading in newspaper that Alwar, Jodhpur, Jaipur, and these are having very poor air quality. There are 5 cities which were designated as non-attainment cities in the state. So, the one we have to take some action on the politic people and the sources of pollution so as to tackle this. But as initially what happens is when there is any air pollution, blame is put up into some particular source, industries, vehicular pollution, poultry burning, and other areas. But then that is not very conclusive. So board has got into agreement with few IITs and got a source apportion studies carried out, so that it can be identified ki what is the contribution of which source and at which location, so that a concentrated effort and effective effort can be taken on those locations. So under that, we have tried to get analyze the carrying capacity of the area, emission inventory, and sources from which these are coming out, so that administratively we can tackle the major areas which are the sources of this pollution. Then we are also getting through CSIR Delhi a noise mapping of the whole state. Noise pollution is a slightly new area. We don't really have taken care of it. Honking of vehicle honking and industrial pollutions and all that. So we are getting a noise mapping of the state is done, so that sensitive areas can be addressed too. Similarly, we have also taken river rejuvenation project of Chambal River. So there are a lot of, what I am trying to say is that this cannot be comprehensive in this presentation, that what sort of projects we are taking. I am just trying to emphasize what state boards approach is. We are trying to identify the gray areas where we need an intervention. We are selecting an agency, research institute or an academic institute which can we feel is competent to do research work or study project on that. And after getting it done, we are sending recommendation to the government or taking direct action at our level, whatever is possible and whatever is required. So our intervention with the academics is that we need a support. We need a research support. We have issues on hand. We have identified issues. We have some sort of funds available for us. We have guidelines to sanction the projects, and that is the primary role of it. Thank you. That is what I want to brief about the state. If Anything else is required from our side?
Thank you, Mr. Mathur, for the presentation. And of course, it's great. Rajasthan Pollution Control Board is means for curbing the pollution menace in Rajasthan. So you are doing a means in different locations. You have installed the site stations along with the machinery and equipments. So just a few queries from our side, and of course we have received one point from Professor Sudhir Kumar Barai, Director BITS. So they would like to means collaborate with Rajasthan Pollution Control Board, or just as you mentioned that you are also looking after means regarding R&D institutions, and just to know from you. Means you have this great infrastructure with you in R&D from R&D point of view for measuring the pollution parameters at different locations. So whether means these stations and these equipment, so uh, so for IEC point of view, say so, do you involve our students, your master students, our research scholars, to let them means know about the equipments, how they function, or means how you operate the things?
Sir, we can always help students, whoever is interested, to understand the equipment. That should not be an issue. If any student want to have a technical visit to these locations, and we can always, we are most welcome to do it. We would be very happy to help the students learn about the mechanisms undergoing along with these students. Though that internships we are not doing, but through the projects which we are awarding, we are already involving students. So whenever we have awarded a project to any academic institute, I can remember from MNIT or that. So obviously the professor in charge is the coordinating officer, but the students as a junior research fellow and senior research fellow and the people who are actually doing work at the field are the students. So I have earlier also mentioned that involving students serve twice the purpose. They are the people who are going to, after in the future, are the persons who are going to address the issues. If they are sensitized about it, knows about it, have a feel about it, it's going to always help the cause. And we always get a trained manpower after a few years. And at the present level also, the work they do is very useful to us. We have been able to implement a lot of studies and a lot of projects done by them into this. So we are funding, when we say we are funding a minor project less than 15 lakhs, this is by and large a project submitted by students through their faculty. So if anybody wants, this is on my website, these guidelines are available, and we can always share again the guidelines to anybody it is required. And I tell you, we have tried to try and keeping it simple. We have tried to take up most of the things the way DST is following. So anybody who is preparing a project has all academic institutes know how to submit a project to a DST. So we have tried to align as far as possible it with the guidelines of the DST.
Thank you, Mr. Mathur. Definitely. So we will be in touch with you means regarding doing these IEC activities for our students' point of view, so that the infrastructure, the means financial things that Rajasthan Pollution Control Board has invested in these instrumentation, or means in creating different stations at different parts of Rajasthan. So definitely we will be in touch with you. And so Professor Barai, so if you have any point to share with the Mr. Mathur, and then we will request you for the presentation.
Yeah, thank you, Mr. Sikarwar. Actually, the very nice comprehensive presentation, Mr. Mathur. I think from BITS Pilani, I would be very happy to kind of get connected with you, because I personally myself work in construction and demolition waste utilizations. And that is something which is the activity, which I think one of the activities are there. And we have a pretty interesting group at BITS Pilani.
Thank you, sir. We would be very willing to collaborate. We are also looking, CND waste is a very new area for us also, and we are very looking forward how to address this. Though we have also slightly worked into developing of MSEND out of construction demolition waste. I don't know how to take it forward, but that is a very interesting area to handle.
Absolutely. I'll connect with you, surely.
Thank you, sir. Thank you, sir.
Thank you so much.
Thank you, Mr. Mathur, for the presentation on behalf of Rajasthan Pollution Control Board. Thanks a lot. And now I request Professor Sudhir Kumar Barai from BITS Pilani, he is director there, for the presentation on this R&D infrastructure theme. So over to you, Professor Barai.
Thank you so much. I hope my slides are visible. Am I correct?
Yes, sir. They are visible, sir.
Fantastic. So, good morning to all of you, and thank you so much, Mr. Sikarwar, for connecting with BITS Pilani for the presentation. So, next 30 minutes, I very quickly take you through the journey of the institute at BITS Pilani, at Pilani campus, and of course, what are the R&D infrastructures are available, or the facilities are available. I'm not the specialist in all the subject domains, so just pardon me if I'm not able to give the technical answer, but I will just tell you what is the basic infrastructure. So it will be mostly the pictorial journey. So in terms of the background, as you know, the BITS Pilani has 5 campuses actually. The first campus is in Pilani, the next campus was opened in Dubai, and then it was in Goa and in Hyderabad, and now we have opened up another campus for the Management Institute in Mumbai. These are the campus snapshots. This is at Pilani, this is at the Goa, and of course in Hyderabad, and of course this is at Dubai. Now, in terms of the BITS Pilani today, we have more than 16,000 students, almost like 1,740 PhD students and 865 faculty members. And generally, the placement has been extremely good in terms of the pre-placement offers. It is around, I think, the 720. So what you see is that the research and drive at BITS Pilani has been tremendous, and this shows from the number of research students which are involved at BITS Pilani. And naturally, once you have a more number of doctoral students, you need to have the infrastructure in place. In terms of the programs, we have the various programs in engineering, sciences, biological sciences, the pharmacy, and of course the humanities and social sciences and management. So we have the undergraduate, postgraduate, and PhD program at BITS Pilani in various departments. Now, as I mentioned, that since the institute has been more driven with the research and so on, it also provides the opportunity to go for innovation and entrepreneurship. These are just small snapshots of it, that almost 9 unicorns have been created by the BITSians. 100 plus startups have been incubated or under incubation from BITS Pilani. We are number 3 in India in terms of number of startups after IIT Bombay and IIT Delhi. And you would be happy to hear that more than 7,400 are the alumni who have been startup founders. So indirectly, providing the infrastructure in the institute level basically creates not only for the job seekers but also the job creator. And that is one of the reasons the infra is been very, very important. Now, in terms of a ranking, I don't have to say much, but this is just a snapshot, whether nationally, internationally, BITS Pilani has been on a forefront. As you can see on the right-hand side corner, which shows the QS World University ranking in terms of 13 departments. Out of the 9 departments have been ranked in like top 16. And that is something which is a very proud moment for BITS Pilani. Now, in terms of the QS ranking, it's the most employable campus, as I mentioned, the kind of a training which the students go through because of the great place very effectively. India ranking in 2021 in the university level, we are on 17. And let me just tell you, we are the only private institute which is absolutely non-profit organizations. We do not get any government funds. We generate our own resources and the facilities and funds and infrastructure, everything. So we are kind of self-sustained model, which we do it. In terms of research areas, like we have a present focus areas, because this would give you an idea that if you are working on a niche area of the research, then you require the infrastructure also has to be created for this kind of a research activity. So we are very heavily into the drug discovery, design, delivery, cyber physical system, sanitation engineering, water resource engineering, and of course environmental engineering, smart materials, AI, data science and IoT, robotics, industry 4.0, micro machining. I'm very happy and proud to say that BITS Pilani has a mega project going on on a national mission on Indian cyber physical systems, which is we call it a BioCity. It is a bio-cyber physical system technology innovation hub, DBT supported builder project, National Clean Air Program of NCAP. We are part of that, and we are also partnering with the National Center of Geodesy at IIT Kanpur. The whole this exercise of research is converted into a huge in terms of the impact. In terms of research contributions, our H index is around 131. Our citations are 11.6. Now, coming to the more important part today, because it's Azadi Ka Amrit Mahotsav towards the R&D infrastructures available at BITS Pilani, and to kind of to make you aware about what are the facilities are there. So what I have done is that I have structured into different things. One is the core facility, which are the central level it is available, and then the department level. To satisfy the departmental requirements, we have created a departmental level facility. So I'll just take you to the picture journey, so rather than just getting into that. So the sophisticated instrumentation facility, we have this, if you visit this particular link of the website, you would be able to see what kind of facilities we have created, not only in-house, but also the outside the institute. We provide these facilities and list of equipments and the state-of-the-art facility, which is available at BITS Pilani, which gets exposed. So people can use it on a payment basis. So some of the equipments which we have at this point of time is the NMR, nuclear magnetic resonance, the field emission scanning electron microscope, which is also a very sophisticated instrumentation facility which is centrally available. The gas chromatography and mass spectroscopy, this is also a facility which is a part of our central instrumentation facility. Raman atomic force microscope, these are also so sophisticated instrumentation. I wish to convey that all these research facilities are created by the institute self-generated funds or some of the sponsoring agencies like DST, CSIR, or DST Rajasthan, and so on. So everyone is kind of the part of creating this facility, and this is all has been generated by the faculty members through getting the funds from various agencies. It's sometimes some of the DST projects where the 50% of partnership is also involved, bigger projects. We have a confocal microscope, which is also the part of our sophisticated instrumentation facility. Nowadays, everyone talking about the AI, machine learning, data sciences, and handling a large data and so on. So we have created a high-performance computing computer clusters, which is also a HPC facility, which is across the campus. Everyone is able to use it, whether be it a civil engineer, be it a mechanical or a computer science, or even a chemistry faculty or students who wants to kind of use this facility. So in terms of the high-performance computing facility, so these are all very central facility of a nerve center of BITS Pilani at Pilani campus. We have a nanoparticle analyzers, which are again the facilities which are created for central level. Impedance analyzer. So apart from the facilities which I talked about, the sophisticated instrumentation facility at the central level, which is mainly for the research and development work, for the research scholars within the institute and outside the institute, if anybody wants to use it, collaborators and so on. At the same time, there are certain facilities, though it is not directly related with the research purpose, but sometimes people use it. But most of these facilities also created for the undergraduate student to get exposed and postgraduate student to get exposed. So these are the facilities, what we call, it's called central analytical facilities. So under that, we have these are the basic facilities which we have created. And some of the equipments which are there, like a polarimeter, FTIR, spectroscopies, we have the FTIRs again, and fluoriometer at central analytical labs. And then the freeze-dryer centrifuge, the elemental analyzers, the ultra-fast liquid chromatography, chemidocs, the fluorometers again, and the centrifuge, and so on. So these are various facilities which are available for the undergraduate and postgraduate students, and as and when it is required, the research students also can use this facility. So a huge investment has gone in terms of kind of creating this facility, and in a very well-organized way. They are maintained, they are used exhaustively, and the kind of the academic environment which has been created, where the 24/7 the students can have an access in terms of using this facility. So this is something which is some of the things are there. Cytoflex, we have the spectropolarimeter and anisotropy. These are the equipments which are there. Let me just mention very categorically, these all equipments are not just a showpiece. They are all functional. They are used by the students very, very regularly and exhaustively. The flash chromatographies and HP TLCs and MS interface. So these are all facility as it can be used by the different department students as well in purpose of small projects, what they do, and that actually gets converted into research publications. So these are some of the facility as a part of the CAL. So if you just see that the kind of a facility which it has been shown in the photograph, these facilities partially sometimes from the institute funds, partially sometimes from the project which we receive from various agency. The other very important part is that, as I mentioned to you, is that we are also on the very strong drive on Industry 4.0, and that is why we have created a very central workshop unit, which actually not only gives you the training to the students and research activities, but also open for a skill development kind of a program where the people can be trained. So this central workshop is housed in newly constructed huge building with 13 labs and one classroom, which is spread over almost like 2,600 square meter of area. So just to give you a flair of the flavor of the items, that what are the things are there. Very huge investments have gone. CNC machining tools, two CNC vertical machining tools are there. Again, institute has invested a huge money. The 5 CNC turning centers and the combined centers, turning and milling. This facility is also there. Advanced manufacturing lab, which actually is a state of the art, which talks about a vision machine measuring and the roundness measuring, contour measuring, surface roughness, profile projectors, hardness, and so on. And these are the various activities which can be done under this. We are very proud to say that very huge collaboration is there with the German, not only academia, but also the industry over there. And we have created this learning factory where the people can have a very small learning factory experience in terms of remote data acquisition, smart sensors, and so on. So basically, it's a very interesting experiential learning part of it, facility, which has been created at this one. We also have the fabrication lab, which has a conventional lathes, milling, drilling, grinding, and saws, which is again a very huge facility which has been created for the students. This is one facility which is a plastic processing lab, which has the injection molding machine actually, which is also again can be used for the manufacturing processes. Very common area for workshop is a metal cutting labs. So this has the various facilities, which includes the CNC, the dynamometers, the lapping machines, and so on. So these are various machines which has been part of the manufacturing lab. There is also additive manufacturing lab, which is kind of consisting of the lithography on one 3D scanner, with kind of sometimes our order in expected to arrive anytime from the customs. Basically, that is what we are waiting for the arrival. Now, the sustainable manufacturing and the life cycle engineering is a very important area, because life cycle assessment is of any new material which we develop needs to be checked out, and that is where the various kinds of softwares and the hardware which is required, that is something which has been part of this sustainable manufacturing lab. Welding lab, yes, this is also not only the research students can use it, but also the undergraduate and postgraduate students have an opportunity to have a hands-on experience on the welding lab. There is carpentry lab, which is also again created with a very sophisticated zero dust emission facility, which is again designed on the German tools, Bosch, which has been created for like the jigsaws and mitrailleurs, the planners, the grinders, vacuum cleaners, and so on. And these are the various facility which is there as a part of it. Another part of the workshop is that the smithy and the sheet metal lab, which is again the power press and other things are available for the various activities. The casting lab, that is also another exposure where they are the universal sand testings, the rammers, the moldability test and furnace, etc., are created as a casting lab. So the earlier labs which I showed you are the labs which are more on the workshop, the manufacturing, the industry 4.0 towards that. We are also developing other equipments and so on with the ongoing some of the new projects which are coming up, under which we will be using those facilities and creating those facilities. The next one is that any academic institution must have a very strong IT infrastructure in place, because the IT is the very, very common facility which is required to kind of grow as the communication is becoming much more powerful. So at BITS Pilani, we have this R&D facility for what we call is information processing center. The IPC has a local and external connectivity, including email. This is very, very important because the communication is we have a 24/7, 360 days now in the year, all the labs and centers which are the computing facility. And the people are able to access the computers and the facilities. More than 1,000 latest desktop and workstations are available. Almost like out of that, 350 are centrally located. We have dozens of computer servers with different capacities, multi-terabyte storage abilities, and so on. And of course, the large number of other softwares and compilers, which can be used by the faculty and the students, which has become a very strong backbone of our IT infrastructure at BITS Pilani. Now, there are 7 labs, as I mentioned it centrally. 350 machines are there with a very high-end kind of computing power, and all of them are connected with the high-speed LAN and internet. And that is something which is, again, from a lab point of view, which are available. These lab facilities are used exhaustively by the students for research activities or some of the lab activities, which is part of their curriculum. Now, once you have the lab facility, you need to have the network infrastructure also in place. So we have both kind of infrastructure in terms of the network, like wired or wireless. It is actually follows with a certain architecture, like a core distribution and access, and it has a state-of-the-art network connectivity. Of course, we have the 4 Gbps leased line, which is actually used for faster communications. We are very proud to say, of course, now it's a bit because of the pandemic. Everyone is now moved to various kinds of online platform. But before the pandemic, the BITS Pilani was enjoying, I think, possibly only academic institution, which had a fantastic facility of a telepresence video conferencing, where we could connect our all 4 campuses with just a touch screen. And that was a very important facility, which was allowing to kind of not only to the review processes, but also conduct various events, the selection processes, the seminars, and so on. All these things were possible by just sitting in one of the campuses. So this was something which was a very, very interesting facility we had. And now it's absolutely used exhaustively. The another thing is that we are a part of this NCAN scheme supported by the Ministry of Human Resources. Now it's actually MOE. The other IPC computer servers are there, which is also very important from the point of view of the higher end, the HPC, high performance computing support, which we have to provide to the students and the faculty member. So this is also a part of the infrastructure. These are some of the commonly available softwares which are useful at a larger scale for research activities. So all the softwares are available, which are made available to the students centrally. Now, I'll just talk about the engineering departments at BITS Pilani, coming from central now to the localized level, trying to explain that what are the different facilities are available in various departments. I'll quickly take you through the snapshots of engineering department's facility, which will give you an idea that what are the facilities are at various departments, because that is something which is also very important in-house facility. So first I'll start with the civil engineering. So at the civil engineering department, recently we have hugely invested in advanced research in environmental engineering and a fecal sludge management lab, and a huge amount of money for various kinds of equipment and the facility for this sanitary engineering program, which is actually has started, and then sanitation program basically. So that is a program where various kinds of these equipments have become a part of the research and also the teaching experiences. So this is something which is there. The other lab which is there is called Concrete Technology Lab, where we have various kinds of equipments available. The list of equipments are given. These are the equipment which are used for concrete technology studies. We want to innovate and look for the new kind of concrete materials and how do we carry out the research activities. So this is a part of the concrete technology. The other is the environmental engineering lab. It is actually exhaustively used again by the undergraduate, postgraduate students, and also research students. Here also we have various kinds of the equipments which are essential to do the research work in terms of the research activity. So to just kind of to show you the pointers. Okay, so these are the various equipments which are there in the environmental lab. Geotechnical lab, again, this is the lab where we have various kinds of facilities for the equipments which are there as a part of the mechanics point of view to understand various kinds of studies to do. So this is a machine for the direct shear stress. Okay, now the coming to the hydraulics engineering, we have the hydraulics engineering lab, which has a lot of other equipments which are part of the hydraulics engineering. Now, this is also another facility which is available for basic hydraulic bench, which is used for the undergraduate students largely. Another one major facilities again created at BITS Pilani in the structural engineering labs are the various kinds of test facilities which is required for the structural engineering activities, research activities. This is the servo hydraulic actuators assembly, which is also very happy to say that DST FEAST has a very huge grant has been given to build this facility. Other things are like a surveying lab. Again, the surveying, we have the state-of-the-art all equipments, differential GPS to all the facilities, total station electronic, this theodolite and so on as a part of this. The other one is the transportation engineering lab, where again the various equipments which are part of the research activities, which is also become a part of the transportation lab at the Department of Civil Engineering. And this is, of course, a wheel rut tester. The next one is the Department of Computer Science and Information Systems, where again the network research labs, which is again a lot of research activity which requires very heavy equipments. And these are the various equipments which has been created as a part of the network research lab. Then at the embedded systems and robotics lab, a lot of research activities which are done for the robotics level for various defense related agencies and so on. These all activities has the different kinds of robotics clubs, robotics societies, robotic research group. They are exploiting this facility for the research activity. The another one is, again, as I mentioned to you about the data analytics, is a very, very common area which requires a huge power facility. So this is where we have the parallel technologies lab for the advanced data analytics. So this also facility has the another one is the multimedia and human computer interaction lab. That also requires the other kind of vision related cameras and all the facilities. These facilities are part of the multimedia and SCI lab. One more area which is now catching up with the web intelligence and what we call social computing lab. So that again also is the area where we have created the lab facility with the certain kind of servers in the facility. And of course the software defined network lab, which is also the part of this one. Okay, now the Department of Chemical Engineering, the analytical labs. I just have another 5 minutes, so I'll just cover up. And then the various kinds of this analytical lab has those various equipments which are available. I'll just go through very quickly to just give you an idea that chemical engineering department also has a various this lab available, and the kind of the different kinds of equipment which are relevant for the chemical engineering point of view. And of course, the electrical engineering has a 5 labs like a VLSI lab, power electronics lab, sensor, Internet of the Things lab, advanced electrical machine lab, and virtual instrumentation lab. These are all the labs which are part of it. And each lab has basically a substantial number of the softwares and the hardwares which is required for the various facilities. So these are all the various research facilities which is part of the research R&D infrastructure which is available at BITS Pilani in EEE department. And the mechanical department has a MEMS lab which works on microelectrical mechanical systems, working from the different kinds of the sensors lab related activities, which is also available in terms of this. So these are related with the MEMS lab. The other one is the new workshop which has a 3D printer, which is a part of the CNC engraving machines. Thermal science lab, again, is a part of the mechanical engineering department. We have the solar air heater and the solar thermal, this one. Workstations for the CFDs, of course, computational fluid dynamics. So I'll just take you to the science department. The physics department has an X-ray diffractometer. Again, DST FEAST has greatly supported to this one. And since it is the DST supported, 50% contribution comes from the private institutes funds and the 50% comes from DST. And that is how we have created this huge facility. And a lot of these success stories based on this research activity carried out on these machines or equipments are actually become a part of the stories at the DST, central DST, Twitter and so accounts and all that. So these are the material physics lab. So this is about the materials physics lab, the chemistry. Again, we have the matrix isolation lab. we have an asymmetric synthesis lab, we have the HPLC lab, we have an inorganic chemistry lab, we have the research equipments for various activities for the hot air oven to the vacuum oven and so on, and the other equipments which are like a high resolution mass spectroscopy, and the instrumentation lab we have, and the research equipment. So what I intend to say is that the sciences department are also equipped with enough material in terms of the research facility at the various department level. Let me just quickly go through the biological sciences, which is the core strength, because it has been rated number 2 in India. So I'll just quickly tell you that we have a different labs like a microbiology, genetics, biology, microscopy, biotechnology, greenhouse, animal tissue culture, and plant tissue labs, which are available at the biological sciences department. And these are the snapshot of various labs, and these are the equipments which are available at the biological sciences lab. In terms of the various facilities which are there, again, I'm very happy to say that the Department of Biotechnology, Department of Science and Technology, and so on, all this department has contributed immensely through our faculty projects, and that is why we could build this facility. And it is exhaustively used by the faculty member. These are the infrastructures at the pharmacy department, including the various kinds of equipments which are used by the department students for the pharmacy related activities. So these are the R&D infrastructure for this one. On closing remarks, I just want to say some of the things that we are also very proud to say that the economics and finance, which is a very common subject domain where the students get more employability, so which we call is a financial engineering, and the management department. So we have also the Bloomberg terminal, which is actually is a very huge facility for the students to have a hands-on experience on real-time data and so on. Humanities and Social Sciences department has a language lab and creative media lab and music lab. BITS Pilani has been always on the forefront of being the teaching institute as well. So we have a very interesting teaching learning center, and there also we have facilities which have been created, the classrooms, the libraries, and IT supported classroom and telepresence. All this has become a part of the teaching learning center. And we are kind of using it very, very exhaustively, including creating the course content and the creations and making it available. One of the very important things is that the BITS Pilani is a work integrated learning program. More than 20,000 students are in the industry, are getting trained through our platform. So we have a very good, solid online platform backbone through which we are able to disseminate the knowledge to everyone. Just as a closing thing, I wish to tell, because Mr. Manu Sikarwar is here, so I would like to tell that we have certain views from our R&D activities point of view in Rajasthan. As you must have seen, I did not talk about too much about the research here, but basic infrastructure, keeping the theme in mind. I have just a request that the DST Rajasthan has been giving a project. I am very happy that we have received 6 projects from DST Rajasthan. 3 are already completed, 3 are just ongoing, and so on. It would be very nice that it can be in terms of a human resources grant and equipment grant. It is more very close to the central DST kind of a funds, because the scholarship which are given to the research students and so on, they are not matching with the kind of in the present trend. So just I have a request that through this I wish to convey that if you can make a point and convey this point that the concern, because then what will happen is that it will enthuse more and more research scholars to kind of come and join under these projects as well. And these collaborations, we are okay with the partnership part of 50-50 and so on. So this is something which is there. We are very open for collaborative research activities with any of the Rajasthan DST supported any agencies or institutes are there. We would be more than happy to do that. We will be very happy to provide any needy academic institution or industrial organization to have an access to our research facilities, because we would love to have a partnership and collaborations with everyone. And of course, we are always open for state level. Any activities would be there. BITS Pilani, as for the students, for the community, for the state, for the country. And because that is what the main the point is. Azadi Ka Amrit Mahotsav is just not a celebration. It's a celebration of making our facilities accessible to the most needy people, so that we can share. And sharing is actually all about learning from each other and growing together and so on. So thank you so much, Mr. Sikarwar, for giving me the opportunity. I hope I have finished on time. Thank you so much.
Thank you, Professor Barai, for this very nice presentation and sharing all the R&D infrastructure available at BITS Pilani. So just to apprise you, since you have raised one query regarding this R&D related project supported by state DST. So just to apprise you, so the department has decided to provide the fellowship for JRF and other scholars at par with DST Government of India. So
Wonderful.
probably for the new projects that we will be advertising. So we will be providing JRF fellowship at par with DST Government of India. And so Professor Barai, so I have a couple of queries here. So since Department of Science and Technology Government of Rajasthan, we do provide support to our science students for doing their internships at different locations in IITs, at CSR lab, at DAE lab, DBT lab. So this year we have provided around support to 200 students from Rajasthan itself. So just to know from you whether BITS Plani has any kind of policy to provide internship, means students means outside from the campus, means in case of Rajasthan, so different universities are there, state government universities are there. So such kind of wonderful facilities are created by BITS Plani in biological sciences or even in life sciences. So means have you any kind of policy for allowing students?
So let me just state that at this point of time, I'm not very aware about any policy, but I have not seen many students coming in. But however, we are open for the kind of the idea, and I will just definitely talk to the postgraduate dean, discuss with him, and how really we can facilitate. Maybe even our experiment based we can start, and then we'll just see. Because generally, what happens, our own students go out; they are not generally here during the summertime. And summer being very hot here. I don't know how many people would like to come down to, but Rajasthan student possibly might be interested. But yes, I think as I said that it's about growing. So it's about growing. Then if some proposal comes, definitely we'll review it and we can kind of explore the possibility. Definitely. But at this point of time, if I'm correct, it is not there.
Okay, fine. And another so just another point is that this about this supercomputing facility, this HPC facility.
Correct.
So since means many financial resources are required for creating such kind of facility in any institution, and this HPC facility is one of the wonderful facility. So those people who are working in basic science and even in engineering, so whether you provide any sort of remote login facility to those faculties or scholars if they are from Rajasthan, from different institutions.
Yeah. So let me just tell you that at this point of time we were in a process of or even we were talking to DST, Central DST, about setting up the nodal hub of national mission on a supercomputing at BITS Pilani. Somehow we did not could not pursue because our own HPC facility is very limited and very exhaustively used by the various departments. You might have seen even some of the department has created localized HPC facility. So having that access would be slightly difficult, to be very honest. But I would be very happy that if you can support us in our proposal, where we are ready to take responsibility of creating the infra here as a part of the national mission of the supercomputing in a Rajasthan. So in a complete Rajasthan, we should be able to kind of provide the facility. In fact, I was talking to Mr. Milind Kulkarni, if I'm correct, from DST. We had just initial dialogue, but somehow we could not push it to the next level. So if you can just help us, I would be very happy. We will create the space, we will create and we can then create the remote login as well. Then everybody would be benefited.
So thank you, Professor Barai. Definitely, it's a really good idea. Means if such kind of facility means is developed at BITS Plani, then it will be very nice for means at least users from state, so they can access such kind of wonderful facility. So thank you, Professor Barai. And since you are open for collaboration, then definitely we will request you for there are lot many things. So we will come to you and we'll work out the things. So thank you, Professor Barai, for making the presentation.
Thank you so much. Thank you.
Now I would like to request Professor Ashish Bhatnagar from Maharshi Dayanand Saraswati University. Professor Ashish Bhatnagar is the nodal officer at Rashtriya Uchtar Shiksha Abhiyan RUSA, and he's also coordinator of this NAC facility at MDS University. Maharishi Dayanand Saraswati University. It is one of the oldest university in Rajasthan. So although it's not that big enough, so but they have good quality of means faculty persons at MDS University. So I would like to request Professor Bhatnagar for the presentation. Professor Bhatnagar.
Good morning to everybody. Respected Chair, Mr. Sikarwar Saab, and distinguished guests. I'll start my presentation. Ours is definitely an old university, but still, unfortunately, the faculty number has always been very small. So, whatever we could develop at the university, we are going to discuss, and how we move on our research activities, our project activities, that also will be sharing with you all. Regarding the equipments, I'll tell you that we do have certain good facilities like high performance liquid chromatograph with the photodiode array detector and refractive index detector, capillary gas chromatograph is there with FID, and other gas chromatograph is with TCD. We do have atomic absorption spectrometer, but other than these, some of good instruments, the details, if we want to work out, it is very difficult because you do not move forward like going for MS and other things. But given the system, given the current conditions, normally everybody goes for collaborations and looks for etc. So the same way we also move on. The good thing about MDS University is that we have developed our facilities in a way that all basic sample preparation, till preparation of the sample, we are really good. We can we have then we also have preparatory labs. We have facilities, millipore water facilities. So up to HPLC grade water we can collect from that. And then after sample has been prepared, we have all sorts of centrifuges, refrigerated centrifuges, etc. Heavy duty centrifuge also we have, which we utilize for the preparation of the samples, and basic analysis, whatever is required, we do for somewhere else. Some of the equipment which I would like to tell you about is that we do have good fluorescent microscopes, both inverted as well as upright microscopes. We have auto gel facilities, auto sock slit facilities with us. There is an auto analyzer also for biochemistry of blood. We have ELISA reader, and then particularly in terms of microbiology, if I'll say, we have biolog facility. Of course, it is a manual machine, but this is one of the good instruments with which you can do multiple substrate analysis, community level profiling of the substrates, which can be utilized by the organisms. These are some of the elements I have collected some photographs of. We have a very good library. It's a 5,100 square meter area which it covers. And since June, 50,000, more than 50,000 books we have with us in the library. There is a lot of digital services available to us other than Delnet. We have this ProQuest, which is having its own around 5,000 full text articles you get from 6,400 titles every month. And then we have Cambridge University Press and Emerald Publishing, from which we can obtain all the latest articles and even archived articles from their sites. Other than this, we had two recognized research centers, one by the Department of Biotechnology as Government of India as Satellite Center for Microalgal Biodiversity in Arid Zones of Rajasthan. This project allowed us to create basic infrastructure of microbiology studies. Like we developed growth room, we had gas chromatograph with FID, and all sorts of basic equipment came through this project. At that time, 12.27 lakhs for equipment was good enough to begin our laboratories. Then we had another center, which was Prosticate Bacteria and Micrococcus Center. It was a collaborative unit of the Center of Research on Bacteria and Archaea under the All India Coordinated Project on Taxonomy by the Ministry of Environment and Forests, Government of India. And this was a project which ran about 13 years. In this project, we procured biolog for oxanography. Some basic things also came over here. And in both the projects, not only these projects, I'll show you a number of projects have come to the university as extramural projects. And many of them, we had the mandate for training. So say, for example, at microbiology, we have trained 26 scientists, teachers, and medicos in the taxonomy and diversity of bacteria, algae, and cyanobacteria. 55 research scholars, 4 persons from even industry we have trained, 1 from NGO. There were 84 students who came for different workshops in these trainings. 2 persons, they completed PhD, 9 MPhils, 28 MSc students also got training in it. And 11 junior research fellows have joined us and worked with us during this period. The university has 4 Shodh Peeth, one on Dr. B.R. Ambedkar, another on Maharshi Dayanand, in whose name we stand for. And then Prithviraj Chauhan Historical and Cultural Research Center is there, and a Sindhu Shodh Peeth is there. All the 4 Shodh Peeth have been created by using the money given by the university as 1 crore for each of the center. Out of the interest of this 1 crore, these Shodh Peeths work. Out of them, they publish some journals, Prithvi Rajan, Tahqiq, Ambedkar, and have published 2 books, Virat Vyaktitva Samrat Prithviraj Chauhan and Aitihasik Kalkram Gurjar. These Shodh Peeths also organize workshops and seminars. Of course, our limitations regarding the faculty are there, so we do not have specific persons who will be working on these aspects of the and as per the objectives of the Shodh Peeth. But someone from the faculty is always in charge and who takes care of continuing the activities. We have Interdisciplinary Research Center, Algae Biofield and Biomolecule Center, which has 9 faculty members involved with this, and 5 departments take part in the research activity through this center. It was the first interdisciplinary research center of the university, established in 2011. That was not funded at all by the university, and we had given for it that we will be doing our activities through extramural research projects only. And up to now, we have generated funds of 96.45 lakhs. Out of this, some equipment of around 25 lakhs also have been purchased. It is the only research center with 5 papers having more than 2 journal impact factor, 1 book chapter published in Wiley, some 26 presentations have been made outside in different conferences and all, and 59 students have been trained in algae. Other than our own students, we also train, we allow whosoever wants to come and join us for doing some trains we are maintaining of algae and cyanobacteria. These are the equipment which we procured through the Algae Biofuel Center and through the different projects. We have facilities developed, some fabrications have been done for land area, for the field experiments, like algal turf systems. We have some isola pits, we have glass fiber pond systems are there for cultivation of algae on solid surfaces as well as raceways. Our strength is our faculty only, and we have very competent faculty. Although we are only 16 members in the entire university, having in different departments, and maximum faculty we have is 4 in management. All the other departments have 3 or 2 or even 1 members. But still, the faculty is quite enthusiastic. You can see up to 2017 we had some 7 departments which had already either completed research projects or were doing some research projects. Unfortunately, after that, since the uh, administration also saw the retirement of many officers, so a lot of administrative work has been given to the teachers, because of which the research has suffered. And right now, only one department has completed, after 17, completed one project and is continuing with one project. One patent has been granted, US patent has been granted, and 3 were in the pipelines, but unfortunately they could not be fructified. Our faculty, 2 of the members, they were part of the collaboration in Earth microbiome project, and as a result, the collaboration, we could become a part of one of the papers which has been published in Nature as communal catalog reviews Earth's multi-scale microbial diversity, and that is, I think, is a feature which are some of the faculties have very good science, 4,000, above 4,000, above 1,900, that means around 2,000. And we do have our field, only 60 members are there. It's difficult to handle large number of specializations because the number of persons is so less. We have a lot of administrative charges with us. So because of that, research and nowadays even teaching gets suffered. Challenges to us and equipment procurement since last 10 years, including through RUSA, although twice the tender had been done, but it could not be finalized by the university administration. Frequently, the university is without vice chancellor or without full-time vice chancellor. That also creates a lot of problems. Similarly, there is either no or part-time registrar with us since long time. So all these things contribute to a very difficult time, and because of which the facilities, improvement in facilities is being affected. There are only 4 assistant registrars with us. Even office assistants have charges of more than 2 offices. Almost 100 non-teaching staff and officers will retire in 2 to 3 years. And out of the faculty members also, by 2025, 8 of us will retire. So it is a very grim situation. I didn't want to come up with this at this juncture, but Since the university is going into the reverse metamorphosis of a beautiful butterfly, it had come up with very flying colors. But I request the DST to please convey the government to recruit the faculty. Otherwise, it will be a very pathetic situation soon. Thank you very much.
So thank you, Professor Bhatnagar, for the presentation.
Thank you, sir.
And since means even looking into the number of faculties and means the facilities available at MDS University, but you have really provided these facilities available to the stakeholders from different colleges, from different universities. It's really commendable, and definitely you have the limitation in terms of faculty. But anyway, I think means in coming days, faculty recruitment and other things will be resolved. And state DST is always open. Please do send the proposals for workshops, seminars, and even in intellectual property. If you want any kind of support in filing patent applications from MDS University, please do write to us, and please be in touch with us. And since we have supported around 100 applications in IP domain in the past 1 year from Rajasthan itself, so we are open to your suggestion. And means if any of the professor or means officer in charge from university will write to state DST, so definitely we will be providing the support to MDS University. And thank you for
Thank you.
making the presentation on behalf of on MDS University. And
Thank you
now
very
I
much.
would like to, yeah, Professor, please.
I have one comment, one request to you regarding the patents. We feel problem in getting the attorneys for us. So if the DST can empanel
Yes,
some.
yes, sure. It's not an issue. So Professor Bhatnagar, so what I will do, I would send an email to you, means your
Okay, sir.
colleague Professor Datta, and of course I will write all the technical details in that email, and please do write to us regarding getting the support from attorney point of view, any technical point of view, prior art search and other things.
Okay,
So we
sir.
will definitely support MDS University in this IP domain.
Thank you very much, sir. Thank you.
Now, I would like to thank you, Department of Science and Technology, Government of India, for this opportunity given to Rajasthan Council of Science and Technology and the Department of Science and Technology. And so we would be there for in the next month for making the presentation on different theme on indigenous technologies. So thanks a lot to all my colleagues at state S&T councils, officials at DST Government of India, and other stakeholders who have joined this meeting. So thanks a lot.